Okay, we're going to talk about density today. So, thinking about the question, which is heavier, a pound of lead or a pound of feathers? Hopefully you said that they weigh the same. Okay, they're both the same weight since they're both a pound. But if you were thinking that the lead was heavier, most likely you're thinking of density. If a piece of lead and a feather of the same volume are weighed, then the lead would be a greater mass than the feather. It would take a much larger volume of feathers to equal the mass of a given volume of lead. So, density is the relationship of the mass of an object to its volume. So, density is equal to mass divided by volume. It's usually in the units of grams per centimeters cubed. My pen is wanting to act up. Okay, so we have grams per centimeters cubed or grams per milliliter. We're able to rearrange the density formula, okay, so that we can either solve for mass or solve for volume. So mass is the amount of matter in an object. Okay, it's usually given in grams, so sometimes we will consider this the weight. Sometimes in the problem it'll ask you how much an object weighs. That's referencing the mass of the object. Okay, so if we want to solve for mass, we can multiply the volume to the other side of the equation, and we get mass is equal to density times volume. If instead we want to solve for volume, and volume is like the amount of space that an object takes up. Usually we have that in centimeters cubed or milliliters. Okay, so if we want the volume by itself, okay, I've got to move volume to this side, which means I need to move density to this side. Okay, so volume would be equal to mass divided by density. Okay, so looking at the first example here, we're going to calculate the density of a material that has a mass of 52.457 grams and a volume of 13.5 centimeters cubed. Okay, again, we know that density is equal to mass divided by volume. Okay, so density is equal to, they tell me the mass is 52.457 divided by 13.5. Okay, so in our calculator, we're going to type in, I always like to use the alpha y equals button just because if we're dividing, it makes it prettier. So we are going to type in 52.457 over 13.5. We get 3.8857. I could round that just to 3.89. Now then, for our units. For the units, we have mass divided by volume, so you'll do the same thing with the units. The mass units were grams, divided by the volume units were centimeters cubed. Okay, looking at this second example here. Student finds a rock on their way to school. In the laboratory, he determines that the volume of the rock is 22.7 milliliters and the mass is 39.943 grams. What is the density of the rock? Okay, again, density is equal to mass divided by volume. So we have density is equal to, the mass is 39.943, divided by the volume, it tells me, is 22.7. Okay, so we divide these two numbers here. You should get 1.76. Your units would be mass, which was grams, divided by volume, which was milliliters. Okay, so the third example here. We have the density of silver is 10.49 grams per centimeters cubed. If a sample of pure silver has a volume of 12.993 centimeters cubed, what is the mass? Okay, so here they give me the density and they give me the volume. They want me to solve for the mass. Now then, on your EOC formula sheet, density is not one of the formulas on that page. So you have to memorize this formula. Density is equal to mass divided by volume. At the top of the page up here, we talked about that mass equals density times volume, and volume equals mass times density, or mass divided by density. Okay. That was more so just as a convenience in talking about rearranging the formulas. The easiest way that I can say to set this up is stick with D equals M over V, so that you're memorizing one formula, not three formulas. Okay? So we're going to plug in what we know into that D equals M over V. We have 10.49 is equal to mass, which we don't know, so I'm going to leave that as an M, over volume, which is 12.993. Okay, and I'm going to work this out algebraically to solve for the mass. I'm going to multiply both sides by 12.993. Okay, so if I multiply those together, 12.993 times, I had 10.49. I get 136.297. We can just round that to 136.3. What I want you to notice is what we did here is the exact same thing as the formula at the top. So if you use this formula or the one at the top of the page for mass, you get the same thing, because we took density times volume is equal to mass. So you're still working out the same, but instead of memorizing three formulas, you're memorizing just one formula and then manipulating that formula to solve whatever variable you need. So we get 136.3. For my units, it will be grams. The reason it is grams is in the density part here, we have grams per centimeters cubed. That is mass divided by volume. I already looked, and centimeters cubed was my volume part, so that means grams goes with the mass. Okay, looking at the last example on the front here, a small hammer has the density of 5.5 grams per centimeters cubed. It also has a mass of 2.3 grams. What is the hammer's volume? Okay, so once again, we have density is equal to mass divided by volume. They tell me the density is 5.5. The mass is 2.3. Divided by, I don't know the volume, so I leave that as V. To solve for V, I need to first move it out of the bottom of my fraction. So I'm going to multiply both sides. I get 5.5V is equal to 2.3. I'm going to divide both sides by 5.5 here. So 2.3 divided by 5.5 will give me 0.42. Okay, Okay, once again, up at the top, we said that volume is equal to mass divided by density. That's exactly what we did right here, okay, by manipulating this original formula. So volume is equal to the density, volume is equal to the mass divided by the density. As far as our units go, okay, for volume will be centimeters cubed. Again, looking at density here, it was grams per centimeters cubed. Grams was the mass part, centimeters cubed would be the volume part. Okay. Okay, so let's take a look now at the back of the notes page. Okay, recall the volume formulas. Volume of a cylinder, looking at our EOC formula sheet, we know the volume of a cylinder is pi r squared h. Okay, so we have pi r squared h. Volume of a cone is 1/3 pi r squared h. 1/3 pi r squared h. Okay, volume of a square pyramid. Okay, first, on the formula sheet, we just have a pyramid is 1/3 big B times h. On this part, because it is a square pyramid, for big B, the base area, I would use the formula for area of a rectangle, which is base times height. Okay, or side times side of the square, so all sides would be the same. Okay, so pure gold has a density of 19.32 grams per centimeters cubed. If a cylinder with a radius of 2 and a height of 5 was made of pure gold, how much would it weigh? Again, weight is referencing mass. So on this problem, we're going to solve for mass, but first we have to find the volume with the information they give us. They tell us the radius is 2 and the height is 5. Okay, so volume of a cylinder is pi r squared h. So I have pi times the radius is 2 squared times the height is 5. And we'll go ahead and approximate this answer and include the pi whenever we type it in the calculator. You should get 62.83. So now, if we want to solve for density, for mass, we know that density is equal to mass divided by volume. The density is 19.32. We don't know the mass, so I'm going to leave that as m. Divided by the volume, we found was 62.83. Okay, again, to solve for mass, we multiply volume times density. So I'm going to multiply 62.83 times 19.32. You should get 1,213.876. We can round that to 0.88. For mass, our units would be grams. Okay, so let's look at the second example on the back. It tells me a cone made of silicone has a radius of 16 centimeters and a height of 23 centimeters. If the density of silicone is 2.336 grams per centimeters cubed, how much will the cone weigh? Okay, so again, we're talking weight. This is mass that we're going to solve for here. We have to first find the volume. They tell us that on the cone, the radius is 16, the height is 23. So volume is equal to 1/3 pi times the radius squared, 16 squared, times the height, 23. Okay, so for volume, we get 6,165.9 Again, density is equal to mass divided by volume. So they tell me that the density is 2.336, and that is equal to mass, we're going to leave as m, over the volume we found was 6,165.9. To solve for mass, we got to multiply the volume times the density. So we're going to multiply both sides by 6,165.9. These cross out, multiply these two together, and we should get 14,403.54. Again, mass will be measured in grams. Okay, the last example on the back of the page here. We have the density of lead is 11.342 grams per milliliter. If a square pyramid with 3 centimeters sides and a height of 4 centimeters is built out of lead, how much would it weigh? So this time we have a square pyramid. The legs are going to be 3. The height here would be 4. So for volume, I have 1 over 3 big B times H. I'm going to find big B first, which I multiply base times height, length times width, just multiplying the two sides together. 3 times 3 gives me 9. So volume is equal to 1 over 3 times 9 times the height of the pyramid is 4. 1 over 3 times 9 times 4 is 12. Okay, so again, I'm figuring out how much it weighs, so I'm solving here for mass. Density is equal to mass divided by volume. Okay, so the density is 11.342. I have mass, m, divided by the volume we found was 12. To solve for mass, I'm going to multiply the volume times the density. So 12 times 11.342 gives me 136.104. Again, grams would be my units here. And that is how you solve for the density.